Today, let us review the sums that we have solved in the test. Obtain the differential equations governing the system. Hence, find this printing mistake. Find the force current analogy circuit. So, what are the forces acting on M1? The forces acting on M1 are FK1, FM1, then FB1, FB12, FK2. 5 forces. The displacement is x1. So, what is the differential equation governing this mechanical system? T square m1 d square x1 upon dt square multiplied by m1 plus, this is for m1. For K1, one side is fixed, another end is moving. That's why K1 x1 plus, this is B1. B1 also one end is fixed. That's why B1 dx1 upon dt plus B12. Both ends are variable. Therefore, B12 dx1 minus x, not x2. Many wrote x2 mixed. Many wrote mixed x and x. X1 minus x. It is given as x, not x2. That's why let us use x. That's all. X1 minus x upon dt plus K2 x1 minus x. K2 x1 minus x equal to applied force is 0. That's all. So, if you want to find the force current analogy is asked. Force current analogy. What is force current analogy? For that, M1 becomes, for current analogy, C1 d square phi 1 dt square plus K becomes 1 by L1 phi 1 plus V1 becomes 1 upon R1. Always be related to R. Be related to R. But d phi by dt is voltage. V by R is current. That's why R will be in the denominator. That way you can remember. How to remember C and for M? How to remember C and L? Current analogy C. Voltage analogy VOL. Voltage analogy L. Voltage VO. Voltage. This L you can remember. So C1 1 by L1 1 upon R1 d phi 1 by dt plus B12 is 1 by R12 d upon dt of phi 1 minus phi plus K is 1 by L2 phi 1 minus phi equal to 0. If you want to write in terms of voltage, C1 d phi by dt equal to d phi by dt equal to V. This implies phi equal to integral of v dt. Integrating on both sides with respect to time, you will get phi equal to v integral of v dt. So we have to remember this while converting into voltage. Therefore, d phi by dt equal to voltage means it becomes dv1 by dt plus 1 by L1, 1 by L1 integral of v1 dt plus 1 upon R1. d phi by dt is v1, therefore v1. This is v1 plus 1 upon R12. Phi 1 is v1. Derivative of phi is v1 minus v upon R12 plus 1 by 1 upon L2 integral of v1 minus v dt equal to 0. This is one equation for electrical analysis. Obtain the differential equation governing the system. This is one equation, first differential equation. This is answer for first part. This is answer for second part. Both are partial. We have to find the same way for mass 2 also. If you write the equation for mass 2, what are the forces acting on it? In the direction of displacement, Fm2, Fb12, Fk2, and applied force F of t. These are the forces acting on M2. One more force, that is B2, Fb2. So this is many missed this. Many students missed this B1 and B2. Friction can be seen as dashpot. Friction can be seen as dashpot. So the B, if you miss this B1, B2, the sum becomes wrong. Many students missed this B1 and B2. B2 is, this B1 and B2 is in the wheel. Okay. Now if you write for second mass M2 d square x by dt square. M2, but the displacement is x only, plus B2, already we B2 dx by dt plus B12 d upon dt of x minus x1 plus B12 we wrote K2 x minus x1 1 2 3 4 5 equal to the applied force F of t. This is second equation. 1 and 2 are answer for first part. Now we have to find the electrical analogy. For that, C2 d phi upon d square phi upon dt square plus B2 equal to what? 1 by R2, 1 upon R2, 1 upon R2. D phi by dt plus 1 upon R12 d upon dt of phi minus phi 1 plus 1 upon L2 phi minus phi 1 equal to I of t. This is equation, sorry. This is in terms of flux. Now we have to write in terms of voltage. That is C2 dV by dt, not V2, plus 1 upon R2 V plus 1 upon R12 V minus V1 V minus V1 plus 1 upon L2, 1 upon L2 integral of V minus V1 dt equal to I of t. This is equation B. So how to draw the circuit? Many have drawn the voltage, force voltage circuit, not current. For this, what we have to take? What we have to apply for nodal equation? Kirchhoff's current law. Kirchhoff's current law. How many voltages are there? Two voltages are there. One voltage is V, another voltage is V1. So, if two voltages are there, means three nodes must be there as per current law. Therefore, we have to take one more node, that is V reference. V reference. Now we have to convert the given equation. This is the given equation. C1. C1 is between V1 and V reference. C1 is between all parallel components. No series, many drawn series. All parallel. Current will be divided in parallel circuit. Voltage will be divided in series circuit. Voltage will be divided in series circuit. Current will be divided in parallel circuit. Current should be divided because current source. That's why all elements must be in parallel. Therefore, C1 parallel with L1, that is also in between V1 and V reference, L1. Then R1 is also here only. R1 also between R1. Then V1 minus V upon R12. That is between V and V1, R12. R12 is between V1 and V. L2 also between V1 and V. L2 also between, we have to draw parallel. That's all about equation A, partially completed. Now come to equation B. Equation B, C2. C2 is between B and reference. C2. R2 is between already. R2 must be V and R2 is between B and V reference. R2. R12 is already we have drawn. R12 already we have drawn. L2 also already we have drawn from the first equation. I of t is between V and I of t is between V and V reference. That's all. If you stop here, then also you will get mark. You want to neatly present, redraw the circuit. Otherwise, it's correct only. But you should mark the if you have to mark this nodal voltages. Say you have to mark the nodal voltages V1, V reference. If you mark, then it's correct. But if you redraw the circuit, there you didn't mark, means then also it is correct. No need to mark the nodes in the redrawn circuit. But here you should mark the nodes V1, V. This is one node, this is another node. This is reference node. This is reference node. If you mark all these things, that's all. So how we can redraw the circuit? C1 parallel with L1, parallel with R1, all are connected to the reference. This is in V reference. Then these are all at same potential. then inductor L2 and R12, then C2 is there, C2, R2 and a current source. That's all. Here no need to mention the node. No need. This also no need to mention. That's all.